They 3D printed an orbital Rocket Lab's genius move. Forget everything you thought you knew about building rockets! This isn't some dusty old tale of giant government agencies or lumbering aerospace titans. Oh no. This is about a company that looked the impossible challenge of reaching orbit dead in the eye and declared, you know what? We're gonna print it. Yes, you heard that correctly. 3D printing an orbital-class rocket engine. Can you even fathom that? Across the aerospace world, whispers turn to shouts. It's insane! Too risky for the unforgiving void of space. Utterly impossible. But this is the electrifying story of a gamble so audacious it completely redrew humanity's map to the stars. Section 1, The Impossible Dream, Problem Premise. For decades, the dream of space was shackled by two brutal realities, mind-boggling costs and soul-crushing complexity. Picture traditional rocket construction, a painstakingly slow ballet of thousands upon thousands of custom-made parts. The price tag, launch vehicles bleeding hundreds of millions, sometimes billions of dollars. Space wasn't just a frontier, it was an ultra-exclusive club reserved for global superpowers and colossal corporations. If you were a smaller satellite company, a startup buzzing with a revolutionary idea, or even an entire nation aspiring to the stars, the barriers were monumental. Orbital launches are no walk in the park. Physics is a cruel mistress, demanding engineering perfection down to the last micron. So, the idea of tossing out proven manufacturing methods for something as critical as a rocket engine, the very heart that pumps fire and fury, that didn't just sound like asking for trouble. It sounded like a guaranteed catastrophe. Section 2. Enter Rocket Lab, a new blueprint. Then, like a bolt from the blue, came Rocket Lab. Born in 2006, brainchild of Peter Beck, hailing from the unlikely shores of New Zealand, a nation with precisely zero history of launching anything into orbit. Seriously, zip, nada. From the humble confines of a garage, their mission wasn't merely to reach space, but to utterly detonate the old ways of how we get there. And they moved at lightning speed. By 2009, Rocket Lab had already punched through the atmosphere, becoming the first private company in the Southern Hemisphere to reach space with their Atea-1 rocket, a tantalizing glimpse of their fierce ambition. But their truly audacious gamble, the one that sent shockwaves through the entire aerospace establishment, it sounded deceptively simple, yet was monstrously difficult to execute. What if they could 3D print the core of an orbital rocket engine? Imagine the gasps, the raised eyebrows, the outright scoffing. Sure, 3D printing was neat for plastic toys or prototypes, but for the fire-breathing, high-pressure heart of a machine designed to conquer Earth's gravity? That was a different beast entirely. Section 3. The Rutherford Revolution, Printing the Future. Their defiant answer to this colossal challenge? The Rutherford engine. And it wasn't just a clever piece of kit, it was a full-blown revolution. Named in honor of the legendary New Zealand physicist Ernest Rutherford, this marvel became the world's very first 3D printed electric pump-fed orbital rocket engine. And forget printing a few minor components. No way. Rocket Lab grabbed 3D printing, or additive manufacturing for the purists, and hurled it into uncharted territory. Get this. Critical, high-stress parts like the combustion chamber, injectors, pumps, and main propellant valves, virtually all of them born from a 3D printer. So, why was this such a staggering stroke of genius? First, the sheer mind-bending speed. Rocket Lab could materialize these incredibly intricate engine components in mere days. Sometimes the major parts emerged in just 24 hours. Stack that against the agonizing months of traditional manufacturing. Peter Beck himself dropped this bombshell. Typically, a rocket engine takes months. We can build a Rutherford in 3 days. This blistering pace meant they could design, iterate, test, and perfect their engines at a velocity the aerospace world had never witnessed. Then there's the knockout punch to cost and complexity. 3D printing didn't just reduce the part count, it annihilated it, radically simplifying assembly and vaporizing the need for expensive, traditional tooling and labor. The result? A dramatically more affordable ticket to orbit, And the Rutherford's brilliant design, ditching complex gas generators for battery-powered electric pumps, not only streamlined the engine, but also meshed perfectly with their 3D printing wizardry. Section 4, Rewriting the Rules, the Impact. Once the Rutherford engine roared to life, powering Rocket Lab's Electron rocket, the game didn't just change. It was completely rewritten. Rocket Lab proved, beyond a shadow of a doubt, that a smaller, nimbler, fiercely innovative team could shred the old, dusty aerospace rulebook. They smashed down the towering costs and sliced through the Gordian knot of complexity that had kept orbital access under lock and key for so long. Suddenly, launching small satellites wasn't a distant dream for a wider spectrum of visionaries. It was a living, breathing reality, happening with clockwork regularity and reliability. The Electron rocket, its heart 3D printed layer by layer, began its steady drumbeat of missions, carrying payloads to orbit for a diverse clientele, commercial ventures, cutting-edge research groups, even NASA itself. This was far more than just a new engine. It was the forging of an entirely new highway to the heavens. It broadcast to the world that a nation with no prior space launch pedigree could erupt onto the scene as a pivotal player. It was undeniable proof that radical new manufacturing approaches, when pushed to their limits, could democratize space for countless more. Rocket Lab didn't just hope for easier access to space. They literally printed it into existence, one astonishing layer at a time. Section 5, A Culture of Genius. And that first audacious masterstroke with the Rutherford engine? It wasn't a one-hit wonder. It ignited a relentless culture of white-hot innovation at Rocket Lab. The very same renegade, out-of-the-box thinking that led them to 3D print orbital engines propelled them to tackle even more mind-boggling challenges, like making a small orbital rocket reusable. Another feat many experts had dismissed as just too darn difficult. They even achieved the impossible by reflying a Rutherford engine that had already tasted the vacuum of space and returned, a stunning testament to the ruggedness of their 3D printed designs and their unyielding drive to obliterate boundaries. This insatiable hunger to constantly discover newer, better, more audacious ways of achieving the extraordinary, that's the undiluted essence of Rocket Lab. So, you see, 3D printing an orbital rocket engine is infinitely more than just a clever manufacturing shortcut. It's a testament to a revolutionary mindset. It's about staring down the "that's how it's always been done" mentality and audaciously asking, is there a smarter, faster, more ingenious way to achieve something truly epic? Rocket Lab's Rutherford engine wasn't just a cool piece of engineering. It was their defiant flag planted on a new frontier, a thunderous declaration that access to space could be, and would be, fundamentally transformed. And they didn't just talk the talk, they proved it. Launch after electrifying launch after electrifying launch. What colossal game changer in space technology do you think is hurtling towards us next? Unleash your predictions in the comments below. And hey, if your mind ignites for incredible stories of engineering genius like this one, smash that subscribe button and ring that notification bell with conviction. You absolutely do not want to miss our next deep dive into world-altering tech. Actionable steps for viewers. Challenge the status quo. Never accept "that's how it's always been done." Always ask if there's a smarter, faster, more innovative way. Identify bottlenecks. Pinpoint the most expensive, complex, or time-consuming parts of any process and target them for radical disruption. Embrace impossible ideas. Don't shy away from concepts dismissed as too risky or unproven. True breakthroughs often lie beyond conventional wisdom. Leverage emerging technologies. Actively seek out and experiment with new tools and methods like 3D printing in unexpected applications. Prioritize speed and iteration. Develop the capability to design, build, test, and refine at an unprecedented pace. Learn quickly from every attempt. Simplify complexity. Look for ways to reduce part counts, streamline assembly, and eliminate unnecessary elements. Build a culture of audacity. Foster an environment where out-of-the-box thinking, risk-taking, and pushing boundaries are celebrated. Democratize access. Aim to lower barriers and make complex services or products accessible to a wider audience, creating new markets. Relentlessly pursue improvement. Even after a breakthrough, keep asking, what's next? And how can we do it better? Never settle. Prove it through action. Don't just talk about innovation. Build, launch, and consistently demonstrate your capabilities. 5 best quotes from Rocket Lab, Peter Beck, that revolutionized the company forever. We are not here to build rockets. We are here to open access to space.